Yep. Okay. So found the bug. So the bug. These values were not actually right. This isn't what they have here. Doesn't match what they had here. So I don't know. That should make a difference. I don't know why these are different, but that's not what they have here. I looked at another example, and they had these same values too. So that may have been one issue. Another issue was the way I was handling setting the size of the message was not working. It was actually setting it in the first 32 bits of the 64-bit word instead of the second one. So that was another bug. And then I had screwed this up with the decrementing from J equals 3 down. I had screwed that up. So I fixed those issues, and now we have, so as an example here, we now have a little test here. The quick brown fox jumps over the lazy dog. If we run this, we get this. And if we take a look at the output here in hex, boom. Right. And it's chunking it properly because that's a long message. So we're now getting the right hash value. So what I'm going to do now is I'm going to change this a little bit. We're going to output, the hash is going to output a string. So we're actually going to have it output okay. So we're going to do all this. Once we're done, we have everything ready in here. In the, yeah, that's not right. In the H. So right now I'm just printing that out. Instead, we're going to return a string. So how are we going to do that? We need to include string. And what we're going to do is string. So we have a string, and then we're going to say string in hex. Yeah, okay. Hex H0. Will that work? I'm not sure if that will work. Can I just say, isn't there something like string? String or something like that. STR. And then if we go back to No errors. Did I make a mistake there? So 2F, D, so we got that one, and then C7A, 2D, 2AF, CED, 84, 91, BB7. Why is this different? BB7, 6E3. Okay, so it's not putting the last. Okay, wait. No, it's 5. It's 5. Yeah. I forgot the last one. So, string. Put that all in there, and then. Boom. So now we're outputting a string. So now we have SHA1 working. We've taken a string of a message, and now we're hashing it to a 160-bit number, which we're returning as a string of the hex representation of that number, like we have here. Yeah. So we've got that. Okay. So we have that. So that's a test of the SHA. Okay. Now we assume that works. Now let's do the next thing, and the next thing is Base64 Encoding. So this thing, we can close that. It's got a bunch of typos. It's got a bunch of errors. Wasn't happy with that. But we now have this working. Boom. SHA1. Simple as that. Yeah, simple as that, really. This is it. That's all it is. Pretty simple, pretty straightforward. Takes in a message, gives you a hash as a hex value. So now what we need to do is Base64 encoding. So Base64 encoding is taking a stream of bits. We need to then break it down into 6-bit chunks. And then that can be represented by a number that we can then look up in this table here, and that gives us that. So if you have this binary number, we have MAN. And then the other thing we need to do is padding, where we need to pad that. So now we're passing in a string, but it's a hex string. So this is actually going to be taking a hex string that represents an actual hex number, and we want to Base64 encode that hex value. Yeah, because here it's a string, so you have MAN, and M is 77, which is really 4D in hex. So either you take in a string and you take in the characters as the character value, like M, so it's like 77, and you have the value there, you're good to go, or you take in a hex string where the character you're going to have 4D, and it's not the number 4 and D, it's actually the hex values, and you need to convert that back to a number. So what we need to do is we need to, so it's going to be a specific conversion. It's going to be, and this is going to give us a string as well. Base64 encoded string. So I'm going to call it Base64. Base64, and it's going to take in, this is, I'm actually going to name it hex. Hex to Base64. And I have SHA1. I might rename that. SHA1 just to SHA1. SHA1. Yeah, and then Base64. We have this. So hex to Base64. We have a string. This is a, so we take in the hex. What do they call it? Is it a message? Also have this overview of how this works. That's still good. Okay, we're looking good still. Everything's good there. So for example, you have your string numbers. It's pretty straightforward. It's just the padding that's the only thing that's a bit more involved. But that's all, it's pretty straightforward otherwise, doing this. So what do they call it? It's technically binary data, binary text. So I'm just going to say maybe hex text, hex data. I'm going to call it hex data. So hex to Base64, so it's a hex string. We want to encode it to Base64. So what do? We have our hex string. We need to iterate. We can iterate over. We just treat it as binary, as one big binary number. We can iterate over. So we iterate over each. We iterate over each byte. So we look at. We read 2 characters of the hex string. We read 2 characters of the hex string, that's a byte, and then we convert that to a number. So like 4D, we just convert that to an int. So it'd be like 77. Now that you have this int, we actually have it in the binary format that we need. And so now you can extract those bits that we need, those 6 bits. So we're going to read 1 byte at a time. So what does that mean? That means we're going to iterate over the hex data and look at every 2 characters. So for y is less than hex data dot size. We go by 2. By 2 because we're going to start at 0. We're going to read 0 and 1. And we're going to read 0 and 1, and then we're going to skip to the next one. So how do we convert from a string to that? Well, again, we have this string. use to do that. So, and then we can also say just uint value. So if you say string and we put into the string std hex, and we put in hex data at index I, but it's not just that, it's actually a string we want. So it would actually be hex data dot substring. So I don't really want to have to do all these substrings, but hex data dot substring. It'd be faster just to convert the actual character itself. It's hex data. Let's just do it the easy way for now. Hex data dot substring from I and 2 characters, right? And then you just say string to value. So now that value should have that unsigned integer value in it. And let's look at an example here. So let's go up here. Let's look at an example. So this is an example of the SHA. I'm going to delete that. We don't need that anymore. And then I'm going to add an example of hex to base64. We're going to have some kind of hex. And I want to see what we get out of that. So we have an example here, right? MAN, we know what that gives us. So MAN. So let's just see if this works. Oh. So the first one, it's wait, hold on, I'm doing it wrong. I'm doing this wrong here. It should be 4D, and then 61, and then 6E. So it should be, right. It should be, what is it? 4D, 61, and what was it? 6E? 4D 61 6E. 4D 61 6E. First value should be 77. Boom. Which it is. Next value should be 77, then it should be 97, and then 110. The count. Right, the offset and the count. Yeah. What's going on here? Do I have to like clear the string stream after that? Like is the string dot? Do I have to do that? 77. There you go. 97, 110. Boom. Okay. Okay, so this is working. So we're going through and reading those bytes from the hex value. And each byte, we can then extract the actual... really, it doesn't have to be an unsigned int. It's a byte. It's just a byte. It's just 8 bits. But it doesn't really matter. We'll just say that's an unsigned int. Now that we have this number, what do we do? So this is the tricky part. We have to break it into 6-bit pieces. How much time do I have here? Okay, I have about 45 minutes. Yeah, I got about 45 minutes. So pressure's on here. So we need to break it up into 6. So we're going to read the first 6 bits. We can extract the value. We can look up in the table. Give us this new value. Give us this new result. Then what do we do? Well, we have two, because we're reading 8 bits from an 8-bit number, there's always going to be 2 left. So what we could then do is just record how could we do this? We can extract the first 6 bits. Then we could we could have a buffer, kind of. So what we do is on the first one, we read the whole 8 bits into the buffer. We extract the first 6 from the buffer, clear the other values. Or no, bit shift it to the left so that these guys go to the top. Then on the next time, we read this, so we have this number. And then we want to then write this into the buffer. So we're going to have these 2 existing that were already in the buffer at the top of the buffer. And then we're going to write the last 8. So we'd want it to be 10, a buffer of size 10 bits. So you always write this value at the end of the buffer. So you have these at the front of the buffer, then you write this into the buffer. So now the buffer is all of this, and then you extract the first 6, and then you bit shift to the left so that the buffer now begins with that, then it has zeros. Then this guy comes in and writes his 8 bits into the buffer, but then the buffer's going to have... The buffer's going to keep getting bigger, isn't it? Right? We read 6, so we have 2 left. And then now we're only going to use 4, so we're going to have 4 left. Now we're going to have, so we have 4, we're going to read 2. So we're going to have 6 left. Right, it's going to do that, then it's going to have 6 left, and then the next time you're going to read it, if there were another number here, if there was another number, you'd start again, right? So you have 6, 2 left, and then you have 4 left. When you read this value, you're going to read this into the buffer. So the buffer has to be, I think, two blocks of 6 bits. So the buffer has to be, I think, 12 bits. When you read this in, well, you now have this value, boom, but this is 6, so you also have this. So now the buffer's empty, you're back to square one. If you have another number, you would be starting back over again. Okay, so what do? We read the value into the buffer. So you write the whole value into the buffer. it's there. And then once it's in there, you extract the first 6 bits, and then bit shifted to the left by 6, right? 1, 2, 3, 4, 5, 6. So then the buffer would now have this at the beginning, and then all zeros. Then you read this into the buffer, and then you'd extract the first 6 bits. But it's always... How do we know where to get those 6 bits from the buffer? I think you have to go all the way to the end. So it's a 12-bit buffer, so when you read a value into the buffer like this, you read it into the buffer, we would have to bit shift it. This is 8. If the bit shifted by 4 to the left, so that we can then extract those 6 bits, and then we bit shift it by 6. So that these two would be at the front of the buffer. Then when you read this guy in, I've got to draw this out here. So the buffer is initially empty. Then we're going to write 0, 1, 0, 1, 0, 0, 1, 1, 0, 1. And then we're going to extract the first 6. So we're going to read the first 6. It's just, how do you know where to... We're going to have to keep track of where we are in the buffer as well. So, okay, you write it into the buffer. We extract, and we know our position of the front, the head of the buffer, the beginning of the buffer is at is 6 bits in, or 8 bits in. We read 6 bits from that, and now, so we read these 6 from here. And now, because we read 6, we then bit shift 6 to the left to bring this at the head of the buffer. So now the buffer has 0, 1, and because we're 6 in, it then has 0, 1, and then the rest is all 6 zeros, right? So we're going to read that. Then we're going to, and we're pointing here, right at bit 0, 1, 2, 3, 4, 5, 6, 7. We're looking at, so we're at bit 7. Bit shifted to the left by 6. 1, 2, 3, 4, 5, 6. Yeah. Bit shifted to the left by 6. Then we have 0, 1, and then the rest is all garbage. We don't care what that is. Right? And we're still pointing here at 7. So every time we just write at the lower part, is that going to work? Then this guy comes in and he writes 0, 1, 1, 0. Yeah, see, that's not going to fit the buffer. The buffer almost has to be opposite. Right, because it's first in, first out. So we have this. We read that. Now we have 2. Now we know there's going to be 8 more coming in. So we bit shift it to the left, right? We bit shift the 2 to the left. 1, 2, 3, 4. But then, so we bit shift to the left, but we know there's 2, so there's 6 spots left. The next guy, when he comes in to read, he's going to need 8 slots. So we bit shift to the left, not by 2. We do it by 2 plus another 2. So we actually bit shift it by 4. So we go left 6 plus 4. So we go left 10. So then we can have 0, 1. And we also move that as well. So we were initially pointing at 7, the 7th bit. Now we moved by 4, so now we're pointing at 11, the 11th bit. Is that right? Because then when we read it, we're going to have 0, 1, 1, 0, 0, 0, 0, 1, right? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we just read this in, right? So that's the 7th, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So we bit shifted to the left by 1, 2, 3, 4, 5, 6 by 6. 1, 2, 3, 4, 5, 6. Right. 1, 2, 3, 4, 5, 6. So you're here. Hold on, I've got to write down the indices. Right. Grab the first 6, bit shifted to the left by 6. 1, 2, 3, 4, 5, 6. And then bit shifted to the left another 2. So 6 plus 2, so we actually went left 8. Right? Now you move it. Right. So you were here, 1, 2, 3, 4, 5, 6, 7, 8, right? And now it's at index 9. Right? This is what we read in. Now you're at index 9. So first the index was 7. We read it in. Okay, extract 6 bits from there. Then we bit shift to the left by 8, and then move the index to 9. Read those bytes in again, and now we can extract 6, right? 1, 2, 3, 4, 5, 6. So we can extract 6 there. Now, the 0001, right? We're gonna read 6, which is this. Now the 0001, that needs to move to the beginning of the buffer, and then we're gonna need to have 8 spaces. So you're gonna have 0001, that has to be the head of the buffer. And then after the 0001, we're going to read in the next one, which is going to be 0, 1, 1, 0, 1, 1, 1, 0. Another 8 bits, right? 3, 4, 5, 6, 7, 8, 9, 10, 11. So this has to be moved so that this is now at the 11th, well, the 12th bit, but the index is 11. So the index now here has to be 11. So the index is 7, and then the index is 9, and then 11, right? Because it was 7 plus 2 is 9, plus 2 is 11. So you take this, you bit shift it to the left by... So we did by... So at the beginning our index was 7. We read the 6 bits. Then we bit shift to the left by 7 plus 1, which is 8. And then our index is at 7 plus 2, which is 9. Right? We read the next one in. Is 9, right? Read the next one in, and then we bit shift. We're going to increment the index by 2, so the index will now be at 11. How much do we bit shift it by? Well, we bit shift it by, you were here, 1, 2, 3, 4, 5, 6, 7, 8. It's always by 8 because you always have to make enough room for 8 more after. That's right. Okay. So you're always shifting left by 8. And then you read it in, and now on this last one, you already have everything you need, right? You have 12, because now you have 12 bits. So now you have 1, 2, 3, 4, 5, 6. You're going to read that. You're going to read that one, and then you're going to know that you're going to be able to read the next one, and then you reset. Then you come back, and you reset the the head of the buffer goes back to index 7, and then you can just reset the number to, well, you don't need to reset the number at all. We're just going to read it in. Okay. So, let's do that. We're here. Read that in the value. So read that in, extract the value, then clear. Right. Okay, now we have this value. We're going to need this buffer here. So we have a value. And we also have a buffer. We have a value, we have a buffer. Buffer index is going to start at 7. Yeah, buffer index is going to start at 7. And then we're going to need the output as well, right? So we'll just call it output, or maybe encoding, and what we return is the encoding. So what do we do? Well, we have our value. Our value is an unsigned int, but okay, yeah, the value is always going to be. We don't have to worry about that. The value is always going to be. It's really just 1 byte. So string, we have a value, buffer index. So what do we do? Well, we write that value into the buffer. So we say the buffer is we're gonna, or the buffer is equal to the buffer, and it can be garbage, it doesn't matter what it is. The buffer is equal to the buffer or with the value, right? Take the value, or it with the buffer. Doesn't matter if the buffer has a garbage, we don't care about that. I could just set the buffer to 0, but well, I'll set it equal to 0 just so that it's easier to see. So the buffer is ORed with the value, so now the value is now in the buffer. Okay, the index is 7. Now what do we do? Now we read the first 6 bits from the buffer, starting at the buffer index, which is, so we're going to take the buffer, what does that mean? That means you're going to take the buffer. Yeah, we do have to clear the buffer to 0. So we set the buffer to 0, then we have this. Now we can just bit shift the buffer to the right by how many? Well, it depends on the index, right? You take the buffer, whatever the buffer index is. If the buffer index is 7, we're going to bit shift it to the right by, we only need 6. So we need the last remaining amount in the buffer. So the buffer index is 7. We're going to bit shift it to the right by 2. So, and then there we're going to bit shift it to the right by 4. And here we're going to bit shift it to the right by 6. So 7 minus 5, 9 minus 5. Right. Okay, so you do the buffer index minus 5. So the buffer index is 7. 7 minus 5 is 2, so we're going to bit shift the buffer to the right by 2. That gets rid of everything except for those 6 bits. Now this is actually the value that we care about. So now we're actually going to have these bits. So we're going to have this value, 19 in this case, and then we look up this value in the table. Okay, I've got to type this up in this thing here, so I'm going to have a function do that. Normally I would do static, but script file. Yeah, okay. Basically, we're alphabet defined. So we want to get a char. This doesn't really have to be a function. This could be a map. Actually, that's what it should be, is a map. So const unordered map of an unsigned int to a, well, it's a char. Right. Base 64 table. Base 64 table. So 0 is A. Man, this is gonna be painful. But that's what it takes. Is this gonna work? Yeah. Okay. B, C, D. I think I made a mistake yet. And then there's a padding character as well, but I don't think I need to add that. Okay. So Q. Wait a minute, is there case? Okay, it's all uppercase. Yeah, it's all uppercase. URS, TUV, and then we do lowercase, and then we worry about that. I want to make sure I didn't make a mistake. A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, W, X. And then we're at 26. And we start again. A, H I J K L P S 47. Yeah. 52 is now 0. Okay. Oh. That's 52. This is 53. Right, 53 is 1. 6, 57, 58. 60. 62. Oh no, 62 is plus. 63 is a front slash. Okay. So base 64 table, there it is. Fuck, I just realized I didn't put the actual, man, it's a char. Hold on, I might be able to, I think I know how to do this. If we go to here, control V. Yeah, I don't know how to insert. Okay, I need to look up how to do this. Okay, visual block mode. Press J 3 times to jump down 3. Okay. Press capital I. Capitalized it at the beginning of the line, right? Is that? Oh, wait a minute. So visual block mode. Let's just try it with 3. If I do this character. Oh, okay. So now if I do this, do I have to do capital I? I don't think I have to do capital I. Wait, I think I do. If I hit I does nothing. Right. So I have to do capital I to go into insert mode from there, and then I do this. Okay, so if I do this now, so this is why I'm using Vim now, is because of stuff like this where it's just not doable in other language, in other editors, or at least not as easily as this. Wait. Okay, so that should be that. That should be okay. That gives us the characters, okay. So now what do we do? Well, now that we have this, this gives us a buffer. This gives us the actual number here, right? So this is a number, an unsigned int that we can then look up in this table mapping, which I named Base64 table. So Base64 table. If I look it up by that, that should give me the character code. Let's confirm that that's actually working properly. It's an unsigned int to a char. Is it because I don't have parentheses? Wait. Why is that a problem? No operator matches operand. Operand types are yes. Well, okay. If I do buffer, is that okay? What the hell? It's an unordered map. You int to char. I mean, it doesn't have to be. It could be an int or it doesn't matter if it's signed or unsigned, really. It still doesn't work. No operator matches these operands. What? Operand types are... This is so easy to look at, eh? This is why C++ has gone off the rails. Look at this. Operand types are const std ordered map of int char, std hash of int, std equal to int, std allocator of std pair of const int. Look at how complicated this line is. This is insane. Int. Oh wait, is it because it's const? Okay, it's because it's const. And so I can just make, it doesn't have to be an unsigned int. It doesn't have to be an unsigned int, but okay, it's because it's const. So this will modify the table. So I think you have to say like I can say find for, and that's fine, but I can't say isn't it because if it doesn't exist it will add it in there? Is that why you can't? Okay, well then let's do that. Let's I should do this stuff in Vim. Okay, delete, and then let's go here, paste that in. Find this, and then so iterator is equal to this. I'm not gonna check if it's not present. It should be present. I'm just gonna say dot find second. Something like this. Okay. So let's go back to here. To here. So the value should be 77, and then it should translate the first 6 to a T, a capital T. Right? So the value is 77. We have our buffer. Let's look at the buffer here. Right? So we have our buffer here. That might be too small to see. But we have our buffer here. And not only that, it should be 1 0 0 1 0 0 1 1 0 1 0 1 0 0 1 1 0 1 0 1 0 0 1 1 0 1. Okay. Now when we look it up, we have our char, and it's a capital T. Boom. Okay. Okay. So that works. Let's keep going. So Base64 table find this guy second. That gives us the letter, and now we have this char. What do we do with this char? Well, we're going to add it to the encoding. So I think you can just do encoding. Really, this should be like a, technically we should have a separate string to write into, but I'm just gonna do this way. I think you can just do it that way, right? Let's see. Shit, I gotta go soon. So the encoding is the empty string. After this, the encoding is capital T. Boom. Okay, we're getting there. Okay, so now we've done that. We've written it to the buffer. We've extracted the bytes we want from the buffer, the 6 bits, written into the encoding. Now we need to update the buffer. So the buffer is going to be equal to the buffer. We're going to take the buffer. Our index was 7, right? Now, when our index is, so we take the buffer, we bit shift it to the left by 8. So we have our buffer, bit shift it to the left by 8. But wait, we want to get rid of the stuff we just read. So how do we do that? The buffer, bit shifted to the left by 8, so it's here by 8, so that there's room. And then afterwards we're gonna say the buffer index is +2, right? We're gonna increment the buffer index by 2, but we need to do something here where we need to we need to remove those bits and then only grab the lower ones. Well, what we could do is we could say, well, I could take the bits I had and then I would know how to then just clear those. Well, what we could do is we could say, so take the buffer, bitwise end it with, we want the first 2 bits. And so the first 2 bits are bitwise ended with 3. Bitwise ended with 3, right? 1, 1. So bitwise ended with 3, and then bit shifted to the left by 8, right? So that should just take those bits, wipe everything out, and then we bit shifted to the left by 8. And now our buffer index is at 9. Okay, let's see if this works. So we have the T in the encoding, we have our buffer here. Once we do this, it should shift everything over. Yeah, so you should have 0, 1, and you should have 1, 2, 3, 4, 5, 6, 7, 8. Yep, 0, 1, and then we have all the 8 left for the other guy to go in. And then our buffer index is now 9. Okay, so that's going to be fine for that. Then we're going to come to the next guy. We're going to OR the value into the buffer, which should be fine. It should maintain what it had. And then we have this. Extract, you know, our buffer index is now 9. So we're going to do 9 minus 5 is 4. We're going to bit shift it to the right by 4. That's right. And then take that value, get the encoding. Okay. Again. But this time it's not going to be 3. This time it's going to be the 4 bits. And then you bit shift it to the left way. What is this number? Well, this number is... So here the number is 3. Right, 1, 1. Here the number is... Wait, that's wrong. It's not 3. It's 4. That should be 3. That should be 4. Right. Oh no, that's right. It is 3. So, okay, that's 1. Okay. No, that is 3. So this one is the number is 3, right? 1 1 is. Right, this is 3, and then this one you have. Wait, I'm confusing myself here. Either way, this will work. It's going to be fine. We're going to only take those. Bit shifted to left by 8, increased by 2. We're good to go. But then on the last one, we're going to read 8 bytes in. And then the last one has to be treated differently. Right? The last one, we're going to extract the first bytes. And then we're going to extract the other bytes. I think we could do this a bit differently. We could just take a mask to grab the ones that we want, and then use that same mask to clear them. So, so initially, so we could have a mask that's initially 1 byte, so 8 bits all set, and then what you do here is you're going to do the buffer, end it with the mask, take the buffer, end it with the mask, and then bit shift it to the right by buffer index -5. Right? It's essentially doing the same thing. Well, what's the point of doing that though? We're doing the same. We don't need to do the mask. The mask becomes pointless there. We still need a mask. But so you take the buffer index -5, which is 2, and then 4. It's shifted. Oh, that's right. Okay. Yeah, that's right. Okay, what I'm gonna do is I'm gonna take a break. We're doing pretty good. We're about halfway through, I'd say. I'm gonna take a break, and then we'll go from there. Yep. Okay, we're back. So where are we at now? Sorting out this buffer. So grab that, grab the encoding, that's fine. And then what was the problem? How we modify the buffer. So yeah. Okay. So first we read the value into the buffer. Right, we read the value into the buffer. That's 8 bits. Extract the first 6. That gives us our first number, and then we bit shift it to the right by 7 minus 5, which is 2. So bit shifted by right by 2. Okay, yeah. So that extracts that. Then to then get the other number back, we had this mask here where the mask was initially the whole thing. What was I doing there? This was a few days ago. So the buffer with okay, so that mask there is 3. So you did the buffer, mask it with 3 to extract those 2, and then bit shift it to the left by 8. Then the next time you would have the next time we would have let's say to hex or to decimal. So the first time we're gonna have 1 1, which is our 3, right? Then the next time we're gonna have 1 1 1, which is 15, and then that's it, I think. So the first time you have 3, so you mask it with 3, that extracts the first 2 bits, bit shifted to the left by 8, right? Then you're gonna read the buffer. The buffer index is now 9. We read the buffer in again. Now we do 9 minus 5, which is 4. Bit shifted to the right by 4. Okay, we extract the next encoding value. Now you do the buffer. You don't mask it with 3. We're gonna want to mask it with 15. So we're gonna want to mask it with 15. This is so first it's 3, then it's 15. Then we bit shift it to the left by 8 again. We always bit shift it to the left by 8. Increase our buffer index to 11. We read the buffer in. Now we have now we have our whole buffer size is now 12 bits. So we have 6 bits. So this still works because you do, the buffer index minus 5. So 11 minus 5 is 6. Bit shifted to the right by 6. We grab our first encoding. We're done with that. And then I'm just trying to think of a clever way to do this, but you could just brute force check what the buffer index is. I think what we're gonna have to do, and in the last case we don't increment the index by 2, we just reset it to 7. So we're gonna have to have logic to do that anyway. If the buffer index is equal to 11, and if the buffer index is 11, so we do what we did there, right? We do the encoding here, but we're not gonna do these 2 steps. If it's 11, we're gonna say the buffer index, we're gonna reset the buffer index to 7, which is what it was. I'm tempted to just say fuck it with this, and yeah, I'm tempted to just do this and say if the buffer index is 7, else if the buffer index is 9, else right? So if the buffer index is 7, then we do the buffer is equal to, we do the buffer we just do the buffer. Yeah, I don't know. I'm just gonna do, so if it's 7, we end it with 3. 3 is the mask. And then we bit shift it to the left by that, and then increment by 2. Yeah, in both cases we're doing the same thing, just with a different mask. Well, in the last case, so we're going to grab the first 6 bits, but how are we going to grab the second 6 bits? Well, we could. So, no. If I go, do I have to go? Do I have to do? So I gotta go to the end. So the encoding is plus. So how do you get the last 6 bits? For this, you don't bit shift it to the right. We just end it. So we just do the buffer end with a mask. And what is the mask? We want to grab the first. We've got 12 bits. No, that's not that. We want to grab the first 6 bits, which is 63. Should I do hex 3F to be fancy? Right, I'll be fancy. So that grabs the last 6 bits. End it with that. Grab the last 6 bits. That's our number. Right. And the cycle continues. You just keep going, right? The buffer index goes back to 7, and we just keep doing this. Yeah, maybe we should do something like no, I don't want to do that. If the buffer index is 11, then we do this, reset it. If it's not, then yeah. I don't know which way I prefer to write this. If the index is 11, we do that. 7. Yeah, I don't know. Might just do this. Right, might just do this. 15 is just F, right? And then 3 is 7X. F, and then it's nope. So 7 and then F. Right? I did that right? No. It's 3, which is 3. And then we have 15, which is F. That's right. Yeah, I don't know. Do I need to do X, 3, F, and then 3F? It's fancier. So okay, so that should be that. Now, okay, so that should extract that. Now let's see. Now, what was I passing in here? The example I was using was this one here, MAN. So we should see capital T, capital W, capital F, lowercase u. So encoding is capital T, capital W. Let's just go to the end. Let's just go straight to the end. No, let's just go to the end. What happens? Capital T, capital W, capital F, lowercase u. Boom. That's nice, right? So it's nice. We said first one, the second one, and then the third one, and we're perfect. Now that's basically it. The only other thing to add to this now is the padding. So we get our encoding. Boom. Now the padding. So for the padding, what do we need to do for the padding? Well, okay. So you add your first character, add that. If you finish with this one, if you finish with our buffer index as 11, then we're done and there's nothing to do. But if when we finish, our buffer index was either 7 or 9, meaning if the buffer index is 7, meaning we did this one, then we're in this case. If it was 9, then we're in this one, meaning there's this case. So what we have to do is okay, let's tackle this case first. So we come in, add that, get our value, boom, we're good. Okay, the buffer index was 7, so then we say this is the new buffer value. That's great. And we increment the buffer index by 2. Yes. What has to happen is the encoding has to be different. So You've got this, you grab your value, great. What's going on, Ragnar? Hey, what's going on? Right, okay, we have our 6, we get that, that gives us our T. Then what will happen is there's still, this will now be in the buffer, right? Our buffer, actually the buffer's already gonna have the zeros, we don't have to do anything. After we do the T, our buffer, right, at this point, we come in, grab the encoding, update our buffer, and then our buffer index is now 2, and then we break out of the for loop. At this point, our buffer index is gonna be 9, and this is what our buffer is gonna look like. No, that's not what our buffer is going to look like. Our buffer will actually look like this, plus another 4 zeros. So I think we need to add the case here, and we need to check. Or we check in the for loop. So if the buffer index is 7, then we check. What you doing there, Ragnar? Hey, what you doing, Ragnar? If the buffer index is 7, we then check, are we at the end of the buffer? If so, then we're going to do different things. So if I is equal to, so I won't be at the size -1, I will be equal to hex data size -2. Well, is there a point in doing this? Because, so you have this, you extract that, and then, yeah, instead of bit shifting it, you still do the same mask, you just don't bit shift it by 8, you bit shift it by 4. Right? You're there, you bit shift it by 1, 2, 3, 4. Yeah. Want me to get that for you, Ragnar? Go get it, Ragnar. Go get it. Go get it. Okay. I don't really like checking this because technically, let's say the hex data didn't have 2 characters for each one. Then what do you do? Yeah, I don't know. Buffer. Unless you do something like let's do something like this where we check So that's your mask. The buffer is the buffer end with that, so really this could just be this, right? And the buffer with the mask, so just grab that, and then if it's gonna be -2. If I is equal to, yeah, the length. Right, if I is equal to that, I don't know if I really want to do it this way. It's not that robust because if I is equal to, if I is equal to the if I is equal to x size -2, then we're not gonna do this buffer thing. If not, then we're going to increment the index by 2. Not only that, we then have to say the buffer. Yeah, I don't know if I want to write it like this. Bit shifted to the left by 8. If it's here, the buffer is, well, we're done. That's the thing, we're done, so we don't need to do anything else. I don't know if I want to do all this. If the buffer index is 9, else if the buffer index is 11. Right. So if the buffer index is 9, then that means, so now we're here, that means we have our buffer that has, we've bit shifted to the left by 8, so we need to bit shift it to the right by 2. Right, we went by 8, but we only need to do it by 4. No, we went by 8, but we needed it to be, if the buffer index is 9, then that means we only had 1. So now, so we're in this case, right? So we want to have it with 4 zeros at the end, but we actually have 6 zeros at the end. So yeah, you bit shift it to the right by 2. So you take the buffer, bit shift it to the right by 2, and now you have the value, and that's the value that you're going to use, and we're going to add that to the encoding. So bit shifted to the right by 2. So take the buffer, bit shifted it to the right by 2. If it's 11, then we're in this case. So our buffer is going to have this. those 4, right? What do you want right now? Hey, what you doing? What do you want? So we have 4. So there's 6 zeros after, but we actually want 2 zeros. So we bit shifted to the right by 4. So, right, add that to the encoding, right? I think that's right. Now, add that to the encoding, and because we did that, we're then gonna pad it with an equal sign. Add that to the, right, that's our number, get the encoding, and then add 1 equal sign. Right, so if it's in the case of the 11, we're gonna do the encoding is equal to, we're gonna add this onto it. And then we're gonna add an equal sign. And this is, we're gonna add a double equal sign. So our encoding, okay, same as what it was before. Now let's go to base hex to base64. Okay, yeah, we're doing hex, right? We're going from hex. Okay, so now that was this example. Now let's look at this example. So 4D61, just MA, so 4D61. Right? What do we get? Something that we don't expect. Okay, let's go back here and see what's going on. We get the T. We get the W. We're done. So this is what's screwing it up. The buffer is 256. What should the buffer be? The buffer should be this, which is not 256. Oh no, it should be this plus a bunch of zeros. Right, we took the buffer, extracted F, which is 15, so these ones, and bit shifted it by 8. 256. One, two, three, 4, 5, 6, 7, 8, and then a 1. Is that right? That's not right. Yeah, but how could that be wrong? Because it pulled. Okay, hold on. I'm getting confused now. I'm getting confused now. So we have the T. Our buffer now has. I've got to look at this on the side here. our buffer now has so we had this, extracted that, so now our buffer should look like should be 0, 1. Yeah. 0, 1, and then 1, 2, 3, 4, 5, 6. Wait. 1, 2, 3, 4, 5, 6, 7, 8. I think that's right. Right? 0, 1. So it's our 0, 1, and then 8 zeros because we're going to read the next buffer in. Okay. Then we come in and we read that buffer in. Boom. Right? Behind the 0, 1, we have the rest of that. Extract what we need. We get our encoding TW. We're at 9. So now what we do is we do a mask. So take the bottom 4 bits and then bit shift it to the left by 8. Fuck, I should have gone back there. It should. Let me just do that again. Fuck. So the buffer is this. We're going to take the last 4 bits, which is 0001, right? Yeah, 0001, and then that should be at the beginning of the buffer. So then bit shift it to the left by 8. Right? Is that right? 1, 2, 3, 4, 5, 6, 7, 8. Yes, bit shifted it to left by 8. So now it should just be 1. Ah, fuck, I hit the wrong key. Man. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So again, we have 0, 1. But we actually have 3 zeros in front of that. 3 zeros in front of that. Right? This is our buffer. 3 zeros, 1, and then all that. We're ready to put the next thing in the buffer. But now, and then the buffer index is now 11. Why do I keep fucking hitting F5? We do that. Break out. It's 11. We take our buffer, which is this. We're going to want to bit shift it by 4. Right? 1, 2, 3, 4. Wait a minute. We've got 1, 2, 3, 4, 5, 6, 7, 8. One, 2, 3, 4, 5, 6. No, we got to bit shift it by 6. Why are we doing it by 4? We've got a bit shift by 6. One, 2, 3, 4, 5, 6, right? So it'll be, yeah, that's right. That's where it will be. Bit shifted to the right by 6. Wait, it's in a situation where that's that and that's all zeros. You then want to bit shift it to the right by 6. Right? You've got 6 and then those are 6. So you want to bit shift it to the, because you want to add 2 zeros. So you want to bit shift to the right by 1, 2, 3, 4. 1, 2, 3, 4. Hmm. 0, 0, 0, 1. Man, I'm getting confused here. What's going on? I know, I'm thinking of the wrong case. So this is our buffer. We got the 6. Then we got this guy. Now it's 11. Okay, right. Now it's 11. Our buffer size is now 12 bits. But that's all going to be zeros, right? So the first 4 bits are actually what's relevant. The first 4 bits, the rest is all zeros. And then we want to just move it so there's 2 zeros left. So we want to move it 1, 2, 3, 4, 5, 6. That's right. We want to move it over by 6 bits. So if I do this and I run this, you get 4, which is correct. We get 4. And then if we do a find for 4, let's execute this. Okay, I can't do that, I guess. Yeah, we should have a 4 there. I don't get it. We have TW. How could we have not added anything? Is it that it's not finding this? Is that the problem? No, it found it. Oh, I know why. It's because you can do this, but you can't do this with that. Okay. Sorry about that. This is the problem. So I think this is the problem. I think we have to do encoding. Boom, there we go. So TWE equals. Okay, and now if we go, what's this one? Just the M. Just the M. Just the M should be TQ equals equals. So for this one, we already have the bits are at the left are ready, and then we have 8 bits, right? So we need to, and we're gonna add 4 bits of padding. So we need to move it 1, 2, 3, 4. We need to move it 4. We are moving it. We're moving it 2. Yeah. We are moving it 2. TQ equals. And that's it. That's basically it. Ragnar's excited. Hey, Ragnar. Yeah. Now, let's do some checks. I'm doing it from hex. I'm not doing it from just regular text or just regular. It's from hex, so it's interpreting the characters as 2 of them being part of a hex. So it does have to be a multiple of 2. Maybe I should do a check where if you pass a hex string that isn't a multiple of 2, like so like if we have this I think if it ends with a single hex character, you have to assume that the character before that is 0, right? So I think I'll add that check, and I may even add a check to see, so hex to Base64. Maybe we could say, or if the buffer index is equal to 11. Or if the buffer index is not 7. So if the buffer index is not 7, then you do the buffer index minus 5, right? When it's 9, it'll be 4. When it's 11, it will be 6. And then if the buffer index is 9, if the buffer index is 9, then we do equals, otherwise we do equals. That makes that a little bit simpler, right? Okay. So do an additional encoding. Okay, I think this is good. I think this is pretty good. Now this is hex to base 64, right? So this is okay. Let's just confirm that this is still working properly. So we get TQ equals, and then yeah, and then 6E. Boom. Okay, so we're good to go. We are good to go. This is hex to base 64. I might do another function in the library just to do base 64 from, because it's assuming it's a character string of hex, so it's reading each two as hex. Or you could just pass in a string of characters and it just reads the character as for what it is. So you don't have to do, basically you're just skipping this step. I might actually generalize this and say, instead of hex to base 64, I might just say base 64, and instead we have the data and then the boolean is hex, well maybe from hex is hexadecimal. Data is hex. I'll just say is hex. Is the data hexadecimal, and then we have this. So again, didn't even follow my convention. So, right. Increment is hex. If it's hex, the increment is 2, otherwise the increment is 1. So we do this, right? Yes. If is hex. Actually, if it's not hex, you don't even need a string, right? Yeah. So right, if it's hex, you do this, and then you have to write it into the value. If it's not, then you don't even need to do this, right? Yeah. I could do this. Well, nothing really changes except for that, right? Increment. Typically you're gonna do it from hex, so it makes sense, but if you don't need to do it from hex, then well, let's see. Yeah. Again, I don't follow my convention, right? Is hex should be that. Yep, TWFU. Now let's try one where it's not that way. What's a good test? Oh, okay, just M, right? And it's not hex. TQ equals. Was it MA? The other one. GW equals, yeah. So we're good to go. I think that's that. Let's do a test here. Many hands make light work. Let's do a test of this here. Shit. After the F, it fucks up. TFU, the E is fucked up. And why is that? Do we have 95? We don't have 95. It goes up to 63. Why is it 95? Where are we up to in terms of the character? We're at index 0. W. It did FU. Okay, and now it's starting a new one. We're at 3, right? So 0, 1, 2, 3. So the Y, right? So the value. Right, it doesn't find it. We have Y, which is Y is 121. Why is that not working? Base64. Okay, before we test this, let's test. Before we test this, let's test this WebSocket stuff, which is the whole reason why we started this in the first place. So as an example, it's saying if the key was this, no, if the key was this, concatenate it with this. No, we want to yank this. Right? I'm gonna SHA that. It gives us this, right? And then we want to take this and so this is the hash, and Base64 is actually true. We run into this bug every time. We don't. Is it because we need to clear the buffer? I'm not sure. Is it because we need to clear the buffer? This is what we get. Wait a minute. S3P PLMBI TX8. Fuck yes, man. Boom. All that just to do this. So we take this take this key, concatenate it with this magic string here, SHA hash it, and then take that hash and then Base64 encode it, and we get this, which is what we have here. If I copy this, check, boom, and I think I fixed the bug that we had seen there. So let's go back to here and delete this, uncomment that. Back to here. We're looking for this. Boom. We're done. We are done. That's Base64 encoding. We have SHA1 working now. We have Base64 encoding. We just tested it, and it seems to be doing what we need to do for the WebSocket. So we're now able to, we should be able to do the handshake response. That's going to be next time. What's our time looking at? Yeah, that's going to be next time. Yes.